welcome back to Organic Chemistry Decoded. We are back with more predict the product practice problems. So let's get to it. If you're new here, we're doing practice problems to help you ace the organic chemistry exam. If you're not new, welcome back. You know the deal. So this is our problem right here. If you want, take a screenshot, work through it on your own, come back. If not, we're going to work through this together right now and do the mechanism and predict the product. And before we start this, remember to send this to a friend that you're in organic chemistry with, and like the video and hit subscribe so you get more of these practice problems so you can ace that exam. So we have this here, and now if you see an MS, that's a mesylate. It's like a tosylate, similar to that. And for the purposes of this, just know it's a really good leaving group. So that's going to be our leaving group here. So not just the MS, the OMS. So OMS, that's our good leaving group. So we get primary substrate. We have potassium cyanide. So it's going to look like this. K plus Cn minus. And where is my N? There it is. And so this is a good nucleophile, not so much a great base. So good nucleophile. And it's in acetonitrile. So polar aprotic solvent. And it's in an ice bath. So we have a primary substrate. So it's leaning towards substitution, like more than likely. We have a good nucleophile, not a great base, again, leaning towards substitution, in a polar aprotic solvent. So aprotic means it's not going to likely stabilize an SN1 or E1 reaction. So we're looking at U2, SN2. And we said it's in an ice bath, so it's cold. Remember, whenever you see heat, that's pushing to elimination. And this is the opposite of that. So we're looking at substitution. And like we already have a good nucleophile and primary substrate. So this is going SN2 all the way. And also you might say, well, oh, I don't know, maybe potassium cyanide is a good enough base for this. Well, because it's on this phenyl ring, there's no beta hydrogen for it to grab. So it has to go SN2. There's nothing else for it to even do. It can't perform an elimination on this. So come in. Ooh, no, where's my pen? Sorry, I'll come in. There'd be a bond here. Kick this off. We're going to form our benzene ring. I suck at drawing this so much. Sorry, guys. CH2 and CN. And for those of you that don't know, is a cyanide or cyano group is what it looks like. So looks like that. Ah, made an M. Between N. Carbon triple bonded to nitrogen. So remember, we have primary substrate looking like substitution. We have a good nucleophile, not so great base, looking substitution in a polar aprotic solvent. So it's going to favor a E2 or SN2 mechanism because there's no proton to stabilize that carbocation, and it's in an ice bath. So this is going SN2.